The name of the session is I'm Tracing You, and I'm going to talk a little bit about distributed tracing and OpenTelemetry. My name is Roberto Cortez. I work for Red Hat. Also work for Quarkus. Maybe you heard about Quarkus or not. And over the last couple of years, I've been working on the tracing space, especially trying to bring tracing capabilities to Quarkus. So that's why I came up with this session. Now, this session itself is not Quarkus related. I may use some Quarkus examples, but it will be mostly like generic tracing and distributed tracing talk. So I hope that it will be useful either using Quarkus or not. Okay, so our agenda for today, of course, we're gonna talk a little bit about the state of the art of distributed tracing, especially because I wouldn't say it's like a new thing. It's been around for a few years, but it's become increasingly important and increasingly adopted, especially because like most people now are trying to use microservice architectures. Some of you maybe are using them already. Some of you maybe are migrating. Some of you maybe want to do it. And yeah, when you are using these kind of architectures, you really have to have something on your architecture like distributed tracing to be able to figure out what's going on in your system. And that's when OpenTelemetry comes into place. So we're gonna see what OpenTelemetry is and how can it help us? And hopefully I can do some demos for you in the end, so you can see what exactly we're talking about. Okay, so I talked about microservices before, so maybe you're using them, maybe you're not. So this is the time that you're gonna raise your hands and tell me if you're using them or not. But as you can probably see from the picture, yes, I don't think there is like a huge difference between a monolith and a microservice. All of them are just like a big pile of something. And yeah, we have to try to adjust and adapt to be able to understand what's happening on our system, right? Either it's being like a big monolith or either it's being microservices. Now, on the distributed tracing part, yes, it mostly came out to help on this kind of architecture of microservices, but they can also be used on monoliths. So even though this is somehow oriented to a microservices approach, on a monolith, you're still going to benefit from this kind of technology if you want to adopt it and use it in your current project or in your current product or whatever. Okay, so what's our current state of the art? So when people started to move and migrate to our microservice architectures, of course, we started to add additional complexity, right? Before, when you compare things to a monolith, you have like you have like a big application or a big program, right? And most calls are like internal and yeah, it's kind of like easy to debug. Well, maybe not so easy to debug, but you usually just start the application and you're done. On a microservice architecture, right? So you may have like 2 services, 3, 4, 5, 10, doesn't really matter. But of course, when you have more services, going to be more, there's going to have more complexity to try to debug, try to figure out what's going on. And it's really hard to track what's happening on your system, right? So let's just say you call one service from another. So if you're calling 2 services and one of them fail, it's kind of easy to try to figure out what went wrong. But when you have like 10 services involved on a single call, then things may not be so easy, or they may not be so transparent to figure out what's happening. So I believe that, especially on this area, there are a few questions that you should be able to answer to try to figure out what happened, right? So when these applications are being built and right, you have like a REST endpoint and you call something and everything goes okay, yeah, everyone is happy, right? But when things go wrong, that's when pain starts to arise, right? And then those are the questions you need to answer, right? So what causes the issue, right? Or who causes the problem? So maybe a user have done something that you were not expecting, but what did he do that broke the application, and at what stage? So another question is, when did that happen, right? So what point in time a particular problem happened, and where in the request, right? And when we're talking request, I'm not talking like an HTTP request, just talking request as a generic term, right? So meaning in what particular piece of the application or the system the error happened, right? So those are a few of the questions that you need to answer to be able to figure out where the problem was, so you can of course fix it. Now, this screenshot is like probably like a few months old now. But when I took it, I was trying to buy a PlayStation 5. I actually didn't buy it, I just done it for fun. And I took this screenshot. This is from the Amazon website, right? And you can see here the number of requests that were being executed just to create the shopping detail page for the PlayStation 5. I mean, this for this particular product, but this is not going to be different for any other product that's on the Amazon store. Now, of course, there is some content, some static content that's not really problematic, but you see those XR requests, right? So there are a bunch of them, right? So I count more than 10, and those are required to build a page, right? So imagine if one of them goes wrong, how do you know which one failed? And I mean, what we're looking over here is just like the tip of the iceberg, right? Because what we see as an end user, we only see like the initial request that's being done to a particular Amazon web server to retrieve the web page and to build all the information of the web page, but we don't even know what's happening under the covers. So even if you have all these calls that are being executed to build this web page, we don't even know what's going on afterwards. So we may even be calling maybe like 20, 40, or 50 other services. We just don't know, but still, it's quite impressive. All the requests that are being executed over here just to build these a simple web page. Now this is even more impressive, right? So this is a graph. This was done by in a presentation by an Uber person maybe a couple of years ago. So probably this is not updated anymore. But this is a real graph of the current, well, not current because maybe they already changed it, but the current 2 years or 3 years ago of the Uber system that was built, of course, in microservices, right? And the path that you see is the path when you request an Uber for you, right? So the pink arrows represent the calls that are being executed when you do that request. So you can easily count maybe like 20 requests being executed on the system. This is only the happy path, right? So if there's something that goes wrong, of course, it's going to go somewhere else. But still, when you look into this, you of course you find it very impressive, but also a little bit, in my opinion, daunting in the sense that if something goes wrong somewhere in the middle, how do I'm going to know what make that service fail, right? And how I'm going to be able to fix it? And is it really feasible for me to just bootstrap the entire system to try this out? I mean, it's really a pain, right? Now, this is where, in my opinion, distributed tracing comes to the rescue. And while it's not going to be able to answer all the questions, of course, it's going to be a very huge improvement on a system where you don't have distributed tracing, right? So the idea of distributed tracing is that you're able to track the progression of a request And again, when I say request, it's not an HTTP request. It can be, of course, an HTTP request, but it can be anything else. Request is just like a generic term here. You, of course, can track multiple events, right? So if you have like event-based driven system, you can also track everything that's happening over there. And it even is able to traverse boundaries, right? So when we talk about boundaries, we're not talking. So usually when people think about the system, they always think about an HTTP application, which is like calling other services with REST endpoints. And here, when we talk about boundaries, we're including things like databases, messaging queues, and so on and so forth. So distributed tracing is also, or the idea of distributed tracing is also to go beyond your application and actually monitor the entire system. When we're talking about systems, of course, the database is part of your system, right? Because if you have an application that requires a database, the application is not going to be able to work without it. So the database is part of the system. The same thing if you have like a Kafka queue, the Kafka is part of the system. And the idea is that with distributed tracing, you're going to traverse those boundaries and you're going to be able to track also what's happening on the database, on Kafka queues and more. Okay, so about distributed tracing, there are a couple of concepts that I want you to be aware of, right? So most of the things work on what we call a tracer, and on the tracer you have things like span context, the root span, parent and child spans, and of course you have propagation, right? So the idea is that on the span context you're able to put a lot of information that you want to propagate across the boundaries, and every time you do a jump from one system to another. The root span, of course, it's when you start a particular call to the system, and that's when what we create like a root span. And afterward, then you have like a really nice relationship between parent and child, right? Let's just say that you have a system that spawns like 3 other requests to 3 other systems. Of course, then you're going to have a relationship between a parent and a child. But I have a more visual example, so you can try to figure out what this actually is. So in this particular case, what we want to do is we have like, imagine we have like a bookstore, right? And we want to buy a book. So the buy a book is the entire action that I want to perform. And I mean, this is just, of course, there's probably got a few steps here that that are missing, but this just to have an example, right? So I go and I want to buy a book. I go and I put my credit card details. So of course, I'm going to call something that's going to be process payment, and this is going to generate a span, which is a child of the buy book operation or request. During the process payment, my credit card is going to be locked for the amount that I'm going to get, of course, deducted, right? And after those 2 are over, then 3 new requests are going to be executed. Like we're going to generate like a shipping label, we're going to create an invoice, and going to update stock. And also notice that what you see over here is all of them are like different lengths. So this can represent the duration of the span, right? Especially because if you're executing like multiple things at the same time, they may not, of course, end at the same time. So you have these really nice way to represent this. And spans can even have like a huge amount of duration, in the sense that, for instance, after update the stock, you have to ship the order, then you have to track the order, and then you'll deduct the credit card. But as you probably know, sometimes shipping may take like a couple of days, right? So maybe your system doesn't know about this anymore and you're already done with the shopping. But that's still part of the entire action that the user is executing on your system. So we want to track everything, what's going on. So in that particular regard, what happens over here is that the shipping order may just take like 2 or 3 days afterward, but you're still going to have a tracing context associated with that action, so you can still know that that particular request is part of the original one, which was the by the book. And the way that you do this is using, of course, not only propagating the context, but you have what we call the trace ID. So the trace ID is just a unique ID that's being that's generated every time you start a new trace, right? And then it's propagated across everything on your system. And it doesn't matter if a span is only created like 10 days later, as long as the trace ID is exactly the same of the original action that's being executed on your system. When that span gets populated and then collected to the metrics that are being collected from your system, then of course everything is going to be associated, and you're going to be able to see that that particular span belongs to that particular action. So this is in high level, that's how it works. You start an action, we generate, or it gets generated a trace ID and a unique ID. That unique ID is propagated across the entire system, and spans with information are just being generated and associated to that trace ID. And later on, that trace ID or all those spans are pushed into a collector. The collector will just pick up all the data and will just reconstruct the entire thing by associating all the spans with the same trace ID. So that's high level how it works. Now, the way that you're able to of course, everything that we talk over here is just concept, right? Of course, you're going to need something that implement those contexts, or this concept, I mean. And the way you can do this is a new, well, I won't say it's a new project because it's already a couple of years old, but it's called OpenTelemetry. So maybe you heard about this, maybe you haven't, but let's talk about OpenTelemetry. So OpenTelemetry is actually a merge between OpenTracing and OpenCensus. So maybe you heard about these projects before. So those were some of the initial projects that tries to work on distributed tracing. And both OpenTracing and OpenCensus, they have like some similarities. They also have a couple of differences, and both communities, they just decide to work together and start something new. Well, of course, to bring all the community together and try not to compete on this space. So the interesting thing about OpenTelemetry is actually a cloud foundation project. So it's a completely open source project. Most, or I won't say like all, but I guess most of players that are interested in this space are involved in that. So cloud providers like Amazon, Azure are involved on that. Tooling like New Relic, Datadog, Splunk, and others are also involved into that. And of course, containers and runtimes are also involved into that, like Quarkus and Spring folks. So it is interesting because you see all of these people are collaborating on this, because the idea, as you're now probably figuring out, is okay, especially on a microservice architecture, you may have things that are Java, things that are Ruby, things that are running things on Datadog. I mean, you have like multiple tools running around, and it will be very silly if all of this effort will just stop because you're running something in Java and then you get to a system that's running on Ruby or Python, and then because it doesn't know about OpenTelemetry, then there is no propagation anymore. Well, the good thing about OpenTelemetry is that every concept that I mentioned until now, it's not associated to any particular language, right? I mean, everything that I mentioned, it can be implemented on any language. So the OpenTelemetry is completely language agnostic in the sense that it can be implemented on any language, and they do provide support for any language, right? So they have, of course, support to Java, and that's the one that I work on. but they also have things for Ruby, .NET, JavaScript, and so on and so forth. So the idea is, well, you may have multiple services, they may be running multiple languages, but as long as you have the OpenTelemetry libraries on your application, or if your runtime already has like built-in OpenTelemetry support, then everything will be will work very nice, and it will be propagated. It will just collect all the information for you. Now, OpenTelemetry is not only about tracing. So in this particular presentation, I'm mostly focusing about in the tracing portion, but it also has specifications around metrics and logging. I mean, those subjects are also require like a presentation on its own. So when I came up with this session, I thought that it was just better to focus on a particular aspect, in this particular case, tracing, and then later maybe come up with sessions just for metrics and logging, because I mean, it is interesting because of course, they are somehow related, but also they are beasts on their own. So having like a presentation that covers all three will be very superficial. So I think it's better to focus this way. Now, on the OpenTelemetry front, what we have is there is this concept of we call instrumentation. It can be like automatic or manual. So the idea with instrumentation is either OpenTelemetry looks into your application and tries to create the spans on particular points on your code, and it's going to do that automatically. Or if you want, you can of course create your own spans on your own code and just enroll on the current trace that's happening. So there are like multiple options how you can use that. Of course, ideally you want everything to be automatically, because it will be less intrusive to your code and you won't have to change your code. The other thing what we have is what we call the collectors. So I talk a little bit about the collectors, but let's go see and look a little bit more on details about collectors. So the idea over here is you have an application that has the OpenTelemetry library. So it's going to generate all these spans, and from time to time, well, depending on how you configure, all this information is going to get pushed to what we call the OpenTelemetry collector, right? And now the OpenTelemetry collector is interesting because it's kind of like a generic piece, and that abstracts the data, and then you can just send the data to whatever place that you want. So they already have plugins and connectors to pretty much all the tools that you may think of, right? So you can send things to Jaeger, Grafana, file system, so you name it, Prometheus. So the idea here is you have your application, you send data to the application is going to send data to a collector, and it doesn't have to be like a one-to-one mapping, right? You can have multiple applications send data to just one collector or a cluster of collectors, doesn't really matter. And then from these collectors, you can just like push this data again to multiple other systems, right? And this creates a very nice dynamic and a very nice abstraction, because now you're not completely dependent on a tool, right? So if you have, let's just say, your application connected to Jaeger, right? So if you want to change your tool, then it might be a problem. You just go to the collector and you can just configure something else, or you can configure multiple ones. So it has a lot of that flexibility. Okay, so what can I trace? Right, so there's a bunch of things you can trace, and I'll say that you can trace virtually everything, right? So you can trace things as a network, of course, including HTTP clients and servers, databases, gRPC calls, messaging queues, Kafka, ActiveMQs, you name it, exceptions. So there is a bunch of things that you can already trace automatically. And for the things that you cannot trace automatically, well, you can just access to the current trace, and you just trace it on yourself. But the expectation again is that you should not be required to do that work. Okay, so since this is mostly like a Java conference, right? So I'm going to focus on the Java aspects of OpenTelemetry. Even though, as I mentioned, OpenTelemetry is not only for Java. So if you're also working on other languages, you know that's going to be Java library, or sorry, it's going to be OpenTelemetry libraries to include OpenTelemetry on your application. Now, one of the things that OpenTelemetry gives you is what they call the agent instrumentation. So it's something which is completely out of the box. You can just configure your application with the agent. And the idea with the agent is they already provide limited support to the most popular libraries out there. And the idea with the agent is, well, let's just say you have like a legacy application, or you have an application that you don't want to change the code, or it's really hard to put new dependencies on that, or even the runtime doesn't support it. Well, that's easy. You just start your JVM, you plug in the agent, and the agent will just auto-instrument your application, and it will just start collecting some span information from your app. So that's like a very simple way to start. Requires very little configuration, and yes, it's not going to give you probably all the things that you want, but at least going to give you something that you probably don't have right now. And nothing stopping you to go and enhance the agent and create more code to instrument specific pieces of your application. So that's also possible. On the demos, I'm going to show you how that works, and you'll see that's somehow simple to do. Well, not creating a new agent or not creating new agent code, but at least running the current agent. The other approach is you use library instrumentation, right? So OTel is provided directly by the framework and the library. So runtimes like Fokus and Spring already do that. Now, the cool thing about library instrumentation, it also integrates with the agent one. So you can, even if you're running Fokus or Spring, you can run both with the agent, and you can have spans being collected both by the agent and both by the runtime. And they even, like, of course, going to be merged with each other. So you even collect more information. The only downside here, and that's like just, well, not specific for Fokus, but also Spring, is especially now that you see a lot of applications being run into native, either for Fokus or Spring. Of course, the agent approach is not going to work for native because for now, there is no agent support for native applications. I know that's being worked on. I'm not sure if when that's going to be ready, but I know that that's something that it's being experimented and works. Now, this is when you have these integration on the framework or the library or even the runtime, and this is usually transparent, right? So you either like just add the OpenTelemetry extension of the current runtime, and then it will automatically start to collect span information. So for instance, on the Fokus front, when you add the OpenTelemetry extension, all the HTTP requests are going to be collected for you automatically, right? Either server or client. So you start getting something. There is also other things that we collect automatically, but it's just an example. And then if the agent instrumentation or the automatic instrumentation doesn't work for you, well, of course, you're always going to have the option to access the OpenTelemetry API. And the OpenTelemetry API, of course, you're just free to do whatever you want. You can just get the current span, you can add attributes to the span, you can create new ones, right? You just do whatever you want with it. And I'm also going to show an example on that. Okay, so I already talked a little bit about the collector, just the final piece. So which is the exporter. So the exporter is something that you configure on your app, and that's how you're going to export the data to somewhere else. So ideally, you want to use the OpenTelemetry collector, which already has this protocol called OTLP, which is, of course, the OpenTelemetry protocol. And that's the recommended way to do it. You can, of course, export data directly to other systems, like, of course, Jaeger, Prometheus, Zipkin, like I mentioned before. But ideally, what you want is just export things to the OpenTelemetry collector directly, and then from there you can just push data from to whatever place you want. But the idea here is you're always going to require this exporter, right? So the application can export the data to somewhere else, right? So there are multiple ways on how you can configure how the data is going to be exported, but most of the time it's going to be asynchronously, and it's going to be in batches, right? So you may be wondering, of course, if OpenTelemetry is going to have like an impact performance on your app. Well, certainly yes, because of course it's going to be executing more operations that will normally would not be doing, right? It's really going to depend on what the application is actually doing, but we may be seeing like 10 or 15% increase on the load. But the good thing about OpenTelemetry is that you have other things that you can do, like configure a sampler, right? So you can sample your requests and your actions, so not everything's going to be traced, right? And it doesn't have, if you have like a big cluster, it doesn't have to be on everyone and on every single one of them, right? So there are multiple choices that you can make over there. Okay, so this pretty much concludes the slide portion. So I hope that was not too much boring, especially because on a virtual conference, it's really hard to see if people are having a good time or if they're just being bored. But at least I know that most people like demos, so I think we have around 15 minutes for demos. I think that's more than enough. And let's just go and show a couple of things over here. Okay, so let's change to my IDE. And so the first sample I'm going to show to you is I'm going to show you the agent, right? So I have in here just a very small sample, and you can do this for whatever application. So this is not even a Quarkus application, it's just like a Jakarta application that's being executed on Jetty. And well, you see here, there is just like a very simple endpoint, just generating a random number. And you see there is no, well, if I look here, there are a couple of OpenTelemetry things here on my Maven POM, but at least on the code, well, there is the package name, but if I search something over here like OpenTelemetry, well, you're only going to find the package name. There is no OpenTelemetry code involved over here. Now, what we're going to see here is when I run my Jetty plugin, you'll see there is like a Java agent that's being connected to the JVM, and it's passing the OpenTelemetry Java agent.jar, and it's passing some other configurations. But this is just enough to just start to collect span information and tracing information from this application. Doesn't have any runtime or any library that uses OpenTelemetry. So what I'm going to do over here first is, okay, so I have this number API. It's not this one, not this one. Okay, so I'm going to start a Docker Compose. This running the OpenTelemetry collector in Jaeger. I'm going to show you the OpenTelemetry configuration next. And now I'm going to execute Jetty. So I'm executing Jetty with a profile to connect with the agent. And well, you'll see here some logging saying, yeah, OpenTelemetry is connecting with the agent. That's fine. So everything is started. And well, I'm gonna do it here is I'm just gonna curl. Thinking that's not the one. Okay. So yeah, so this generates a number, right? So you'll see like random numbers being generated from that particular endpoint from my app. And what I can do right now is I'll just go to a local host where I have, I can't remember the port. Let me see over here. So I think this is the one. So here is running Jaeger. There you go. And you'll see here is the number API service. I'll do find traces, and now you'll see in full screen. So now you'll see, yeah, I'm calling numbers / generate. There's 2 spans being collected. I can just click and drill a little bit, and then I can drill even more and see what was collected, right? I'll see, okay, this is being collected by the OTel library, which is from Jetty, right? This HTTP route was number generate. It generated a 200 status code. This is the target. And even inside, I'll see that this was the class name that was being called. So numbers resource, of course, if I copy this and I just search, I'm going to find it over here, right? So this is interesting, right? Because even if I don't have access to the code, I can just hook up the agent and I start collecting some information. And the idea with this is the Java agent already has integrations, already has like code that's going to collect this information from some of these libraries. So in this particular case, I'm using Jetty and JAXRS. And so this is what is able to collect, but there is a bunch of things that the Java agent support, even Spring and Quark is out of the box as well. So even if those runtimes don't support OTel, you can definitely use the Java agent to have something out of the box without minimal configuration. Now, looking into the configuration of the OTel collector, as you can see, yes, I configure like a receiver saying, okay, this is how we're going to get the data. So the data is being exported here using gRPC. And these are my exporters, right? I can export by logging. I can export to the Jaeger. So if I want to even add more, I can just add multiple, even multiple Jaegers or other tools that I may want to export with. So this is actually cool, as I mentioned before, because then you can just push all this information to multiple tools. And yeah, there's just like some health check configuration, but it's not really a big deal, right? So yeah, this is like a very minimal set to have and use the agent. Now let's look into using, for instance, the API. So now I have here one that's using the OpenTel library. So the example is pretty much very similar. It's also generating a number, right? So let's look into the code. But what you'll see over here is now I'm actually getting the tracer, and from the tracer I can actually create a span, and of course this is going to be enrolled in the current trace that's being executed, right? So let's see how that works. So I'll execute Jetty run again, and now notice that I haven't put the agent instrumentation over there. So it's just collecting span data by using the library. And so let's just generate a couple of more endpoints, and let's come back to Jaeger. So let's go and find traces. Now you'll see there are like 3 spans, right? So there's before you had 2, now you have 3. And and you still see, okay, this number generates now is being collected by a library that I developed called small array OpenTelemetry. And I'll see pretty much very similar information that I had with the agent. But I do see here is this span.new, and it has like a couple of keys over there. And you notice that this is actually what I just wrote over here, right? So this way it's a little bit more intrusive in the sense that I am generating spans. Library is going to generate some automatically, but I'm also generating spans directly into the code. So this is a little more intrusive, right? Because it requires you to change the code. But you can combine both, right? So I can now run both of these with the agent. And what's going to happen is both agent and both the library are going to collect spans, and they're going to be, of course, all of them are going to be enrolled in the same trace. So now I'm going to call a couple of more curls, and let's go to Jaeger UI. Let's see what we have right now. So now you'll see you have 4 spans, right? And you see this one, this number generated was collected by the OpenTelemetry library, which is coming from the agent. And now you'll see this one actually collected again by the OpenTelemetry library agent. And this span.new was collected by the one that I just made, right? The one that I had on the code. And this one, again, by the OpenTelemetry agent. So now you see that the agent and the library were able to collaborate and create like a very seamlessly trace across the entire system without like bumping into each other. And now things are really tight and nice. So this is like another way you can do things. But I mean, we still have a few minutes left, and I want to show you a really more in-depth example. So what I'm going to do here is I'm not going to show you the code. So I'm just going to run the application. Now this is a Quarkus application right now. So I'm just going to run it as dev mode. Let's wait for that for startup. I don't have a database, so it's going to create a database for me. And this is just like a bookstore, right? So very similar with the example I showed earlier on the slides. And I have a swag UI over here. So 8080, isn't that running on 8080? I think it was, yes, localhost 8080. Okay. Swagger UI. Weird. Not opening on my Chrome, but it did open on Safari. I'm sure. Not sure what's going on. Oh yeah, I know what's going on. Sorry about that. So the problem is I'm still running Jetty over here, which is running on 8080. I think usually I have like a, oh, never mind. Yeah, sorry about that. Let's see. Happens. Okay, there you go. Yeah. Sorry about that. So let me, I have like here like an authorization. Let's authorize. And I'm going to just, I don't have like an option to buy a book, but I have one to create one. So I'm just going to execute like something over here. It's going to create the book. And apparently it did create a book. So it got like a 201. It has like a response over here. But I mean, let's just say I don't have the code, I don't know what happened. So let's go to jährlich and see if I can figure something out. So if I go find traces, now I'll see that I have like a book API over here, and there are like multiple spans. So those are from Swagly. Oh, I have here the post, and actually see like 10 spans, right? So it's quite big. So let's see what happened over here. So we'll see that we have like a post, right? So that's that was the operation that we executed, right? So we'll see the user, which calls a cabra over here, that executed that endpoint, and we see a select. So you'll see now that it's coming from the OpenTelemetry JDBC. And what was this? So we'll see, oh, this was actually selecting a sequence, right? So maybe that was the sequence to create the book. And we'll see like what's the database connection that's being executed or uses, right? So let's keep drilling down, and we'll see ESPN generate a fallback handle, right? So we'll see something was executed over here, which was a fallback. We're not exactly sure what it was. We see like a book's fallback, right? And now we'll see there is like a reactive messaging Kafka over here. So there is like something that's being sent to this destination. So it was received by the Kafka queue, and then it was executed this ESPN fallback ESPN. Okay, so hopefully you're following me. Now we have another selected database, right? And you'll see that selecting a book. Maybe it's just trying to see if the book is already there, and then it's updating the book, right? So the interesting thing over here is, even I haven't seen any code, I already have like a rough idea on what that thing has done, right? So I know that I tried to create the book. There was this fallback ESPN. I also noticed that there is a ESPN over here. So maybe it's trying to get an ESPN for something and it's falling back because it wasn't able to find it, right? But now using that information actually helps me navigate the code a little bit, right? So let's look and say ESPN generator fallback. So if I come here to my code, and this is actually on another project, which is over here. So yeah, I'll find, I did find like a class name, which is the exact same thing. And I'll start looking into this and I say, okay, here is generator fallback. So it seems that if it fails on something, it will just set the ESPN to ESPN fallback and it sends this to a Kafka queue, right? So now you see, so the idea that I'm trying to convey with this is that even I haven't seen the code before, and I mean, of course, I'm a little bit biased because I wrote the code, but you certainly didn't. But just looking into the tracing information, I'm able to figure out what's somehow happening with the request that I executed and try to map it with the code, right? So at least you're not completely blank, and you're able to figure out something just by using this information, right? And now from this you can debug and you can just follow the traces and follow the code and see what's happening on every step. And of course you get, now in here I only have one system, but if you have multiple systems, of course all the information is going to be done over there. So we only have like 1 minute left, I believe. So I'm just going to do like something really quick. I'm going to start like a new service, which is called Number API. So these, to simplify things now, Number API is another REST endpoint that when I create the book, is going to be called to generate the ESPN of the book. So if I go to Swagly again and execute the same endpoint, we get a 201, you'll see that now you don't have a fallback ESPN. And if I go to Jaeger and you see the find traces, now you'll see there's like 6 spans only. And now you see there's another endpoint over here that's being executed, right, on another process even, right? So you'll see this even what's executed on local state 90 and what's the target, right? So now you see I only have like 2 services, but all of these was just nicely put together on the same trace information. So now you'll see which systems were actually involved on that particular action. So I think that we're pretty much out of time, right? So I'm not sure if you have any times for questions. If we have, I mean, I'm more than happy to take them later.
You have 10 minutes if you want.
Sorry?
You have 10 minutes if you want to use it for questions.
Okay, so yeah, let's do questions then. So let me stop sharing. Okay, so looking on the chat, let's see. So there is a question from Marco saying library approach works natively, correct? Yes, that's correct. So on Quarkus, what we did was we did implement the library support directly into Quarkus. So OpenTelemetry does offer libraries that you can put directly into Quarkus and use them. Our approach is you can either use those, but we do try to also add our own libraries that are based on the OpenTelemetry ones, just because some things that do not work completely okay with native. But yes, the expectation is when you're using the library approach, it will work with native, because I mean, it will just be like simple Java code and that will be fine. The span, so another question from Marco is, can you show the span integration for the REST call to number API? Yes, so that's the beauty of that. So you don't really need an integration. So let me just share the screen again. So as long as you have like systems enrolling on OpenTelemetry, right? The only thing that you require is some configuration, right? And that's probably the thing that I haven't shown yet. Now, the way that propagation works on OpenTelemetry between HTTP calls is by sending the context information on HTTP header, right? And what happens is, as long as the calling service and the receiving service has OpenTelemetry integration, know how to send and read the header, then they're going to be able to enroll all the calls into OpenTelemetry. So if we show like the number API, you'll see here there is no specific configuration, right? So there are some configurations I could put over here saying, okay, this is the header that I want to use, but we're already using everything by default. So there is no specific configuration. There's no specific things that you have to use. So in the case of Quarkus, the only thing that you have is you just have the OpenTelemetry exporter to be able to export these spans, right? If I show you the code of the resource, you'll see there is no OpenTelemetry code over here. So I am going to do a find, and you'll see OpenTelemetry. There is nothing, right? So what's actually happening is when book calls the number resource, it was just going to create a header which is going to contain the OpenTelemetry contacts. On the other side of number, it's going to pick up that header, it's going to extract all the information from there, it's going to create the OpenTelemetry context, which includes the trace ID, and it's going to enroll everything on that same trace ID. Later on, what's going to happen is, I'm not sure if I'm able to see that on the logs. I think we're not logging that. But what happens is both services, number and book, they have the OpenTelemetry exporter running, right? So it runs with Quarkus automatically. And it's just going to export the data to the collector that I did run on Docker Compose, right? So collector is going to receive spans from both number and book. And because the spans have the same trace ID, what's going to do is, it doesn't matter if they're coming from different systems, because they're the trace ID, they're associated, and it's going to associate them together. And then that's how you're able to see them. And this is a very nice way. It doesn't matter if you're going to have even more endpoints or even more services enroll in the same call, all of them are going to show here in the same trace ID, as long as the context is able to be propagated correctly. But that's something that we do for you automatically in Quarkus already. So I hope that answers the question. So let's see. Okay, final. So there is a final question. Can you share the code? Yes. So the code is completely open source. I'm going to put here the link. So this is on my GitHub account. So this is actually using Quarkus. So sorry about that. If you want to use something different, this is called on Quarkus Playground, and it has like the clients and the services, everything that I show here, and you have a bunch of instructions here how to run stuff. So if that doesn't work, please let me know. And I'm just going to paste here on the chat. So I think we're pretty much done. I don't see any other questions. So I hope that you enjoyed the presentation. It was very fun for me to be here with you today. I hope that you enjoyed the conference, and please feel free to reach out if you have any questions later, either by OpenTelemetry or OpenTracing. I'll be very happy to help. So thank you so much for joining this session today, and have fun.